Myself, I am Dr. Jntuh. In this class, I am going to discuss with the various process scheduling concept and the operation of processes. Before moving to the topic, we should know what is a process. A process is nothing but a program is going to be executed in a sequence manner. In this process scheduling, the objective of this process scheduling is to switch the particular CPU process frequently, and it is able to interact with the user each time while it is going to be running. The process scheduler selects will be available for the another process, and the program will be executed on the CPU. For a single processor machine, there will be more than one program running the processor. If more than one process is running in a particular CPU, it will eventually wait for the particular CPU when it is to be free, and it is rescheduled after that particular sequence. Scheduling queue. Scheduling queue is nothing but the process will be waiting in a queue while the other process is running inside a system. It is executed in the three conditions. One is job queue, ready queue, and device queue. Job queue is nothing but as a process enters the system, they will put in a job queue which consists of all other process inside the system. The ready queue is nothing but it will resides in the main memory that are ready and waiting to execute in a queue, and it will be placed in a list. It is called as a ready queue. Device queue is nothing but it will list off processor and it wait for a particular input output condition to be executed. So this is how the queuing diagram is represented by using the process scheduling. Whenever the CPU is in an ideal state and it is free, it will assign the object and the process which are waiting in the queue. That is called as a ready queue. Then the ready queue will allow the particular process to run on the CPU. In other words, it will wait for the input-output condition of each and every process inside a queue. Here, the time limit will be given to the particular object. The parent process will create the child or execute the particular process. Otherwise, an interruption will occur and the process is interrupted and it is terminated out of a queue. After that, scheduling is nothing but we are going to schedule the CPU that how many processes are going to be executed in a scheduled time. It is classified into three classifications: long-term scheduling, medium-term scheduling, and short-term scheduling. While coming to the medium-term scheduling, can be added by the multiple programming whenever it is necessity for decreasing the number of processes. Removing the process from the memory, it will store it in the form of a disk and bring back the information from a disk and continue its execution. It is called as swapping. The swapping is classified into two categories. One is swap in and another one is swap out. In the swapping, partially the contents are retrieved from a process. In the swap out, eventually it will bring back all out the process outside of a memory, which are waiting in the ready queue. This condition is called as a swap out. Moving to the next topic, context switching. Context switching is nothing but whenever a process that is running inside a CPU will require another process to perform its particular state, and the particular running process will go to the save state and move as a current process, and the state that restore after doing that different process is called as context switching. Context switching may be occur when an interrupt is occurring in the system. The system need to save the particular current process and it is execute the state, whether the particular state is a current state or the process is running in previous mode. Like that, it should differentiate. Multitasking. As we know that multitasking is allowing the process more than one process at a time is called as a multitasking. Here, there are two processes takes place. One is foreground process, another one is background process. Foreground process can be controlled via the user interface, and the background process will be controlled in a memory unit and running, which is out of a display. This can be executed in an Android mode. Moving to the next topic, operation on processes. Here, the process is classified into two types. One is process creation and another one is process termination. Process creation is nothing but we are going to create a new process via process system call during the execution of a process. The creating process hence called as a parent process, and the new process that is created with help of the particular creating process is called as a child process. Here, this environment is adapted in Unix, Linux, and Windows operating system. We can identify the process by using a unique process identifier. So this is termed as PID number. Usually this is an integer number. This can be explained with the help of this diagram. Consider this is a tree structure. Here the creating process is called as a parent process and the created process is called as a child process. After the child process is created, it handovers all the controls to the particular parent process. During the process creation, the resource sharing is an important concept. Whether the PID, when the process is created, the child process will allocate certain resources such as CPU time, memory files, and input-output devices. The child process will obtain the particular resources directly from the parent process and use that particular resources. After completing the particular process, it will hand over the resources to the parent process. Moving to the next one, the parent will continue the execution with its children while all the process are doing in process. If in another condition, the parent will wait until some of the children have terminated, it will wait for all the child process to complete in the same state. In that case, a new process will possibly having two conditions. One is the child process has to create a duplicate of a parent process. Otherwise, the child process will have a condition of creating a new program and loading into the other process. So this process is called as a fork process. A new process that is created is called as a fork process. Here, both the parent and the child process will listen to the instruction after the command of fork. Moving to the next condition. So this is a condition for a fork system call. Here, the parent process is creating a PID that is called as a fork process. It is classified into the two states. Whether the PID is 0, it will go to the execution mode. Otherwise, if the parent PID is greater than 0, it will send for the wait state, where the parent state will resume for some of the time. So this is the waiting condition of a process creation. Next one is process termination. Process termination is nothing but whenever a process is going to execute its final statement after doing all the operations. This condition is called as an exit state. Here, all the input and output resources which are used by the particular CPU will eventually come out of a system and use of the particular jobs and hand over the control to the parent system call. So the next process is inter-process communication. Inter-process communication is nothing but a communication that is going to be takes place between one process and another process concurrently at the same time. It is classified into two categories. One is independent process and another one is cooperating process. Independent process is nothing but the process that cannot be affected by other process during the execution of a system. And the cooperating process, they can affect by any other process that is executing inside a system. What are all the reasons that are behind whether a process is not being cooperated with that particular condition? Information sharing, modularity, computation speed, and convenience. So these are the four factors, the reason behind the process is not cooperated with the another function. There are two modes of inter-process communication. One is shared memory and another one is message passing. Message passing is nothing but a client and a server is going to share the information mutually between other. Shared memory is nothing but one process is going to share the memory in a safe state. After that, the other process can acquire that particular memory. Moving to the next topic, that is communication model. In the shared memory, the process A is created a process and it is share that particular memory and the memory is being shared in the nearby resources. Whenever the process B is going to start a process, it will acquire the shared knowledge which is stored by the process A and it will takes part in the participation of kernel. So this is called as a shared memory. Message passing is nothing but the message process. In the message process, the process A is shared and it is shared with the kernel memory directly without any interference of the other process. Here also the process B is being stored that particular memory and it is directly interacted with the kernel. The next topic is shared memory system. Shared memory system, we can say that here a process is creating and sharing a memory to the other process. For example, we can say that producer consumer problem. The next topic is IPC, that is inter-process communication. It is nearly nothing but message passing system. The message passing system will provide a mechanism to allow the process to communicate and synchronize with the different types of address space. Here we can send a message or receive a message in the format of a fixed and variable in size. Fixed size means we cannot change the particular size of a variable during the execution of a program. Variable size, it will require complex addition problems and the multi-programming concepts which can be shared throughout the system. Thank you.